So hello students, in this video we are going to see the rectangular coordinate systems and its elementary application. So as we discussed in the previous video or the first video of this, there is something called horizontal line which is given here, and it will be called as x-axis. There is something called vertical line which will be called as y-axis, and these x-axis and y-axis will divide the plane into four equal halves, four equal quarters. So this quarter will be called as quarter 1, so I will denote it as q1. This quarter will be called as q2, this quarter will be called as q3, and this quarter will be called as quarter 4 or quadrant 4. Now what is a typical feature of these quadrants? In this, the values taken on x-axis are going to be positive and values taken on y-axis are also going to be positive. So all points that are represented in this quadrant will have x and y with positive parity. If you look at the second quadrant, that is q2, it will take all negative values on x-axis and positive values on y-axis. So the parity of this is minus plus. In a similar manner, if you look at q3, in this case this will be minus 1, minus 2 and minus 3. Therefore, the parity of this quadrant will be of this form, that is minus and minus. Now the only quadrant that is remaining is quadrant 4. In this case as you can see, the y values are negative and x values are positive, therefore the parity is positive negative. Now when I talk about positive number or a negative number, I am actually ignoring the fact that 0 is also included in the number system when we are considering set of integers. So that number typically is treated as a special case where you actually say that this x-axis that is given here, or that is this axis, will have numbers of the form, let's say on y coordinate they will take the value 0 and on x coordinate there will be either plus or minus sign. This is the classification of x-axis. In a similar manner, I can translate the classification of y-axis, which is the vertical line as on x-axis it will take the value 0 and on y-axis it will take the value plus minus. Still, I am not classifying a point which is actually located here, and that point is nothing but 0 0, and that point is named as origin. So this is a typical classification of a rectangular coordinate system. As I mentioned in earlier video also, the name rectangular is suggested because this angle between the two horizontal and vertical line is 90 degrees. Therefore the name angular, that is right angular coordinate system. So what is the use of this right angular coordinate system? Essentially, given a plane, if you place this rectangular coordinate system, you can uniquely identify a point. So now every point on this plane has a unique identification. That is the use. So in particular, when I talk about calculating distances or distance formula, let us say these 2 points are given to you, A and B. Now I want to find the distance between these 2 points. How will I find the distance between these 2 points? So the simple answer can be, you simply place a rectangular coordinate system over here, and remember, you are always free to keep the rectangular coordinate system handy for you. So here I am placing a rectangular coordinate system. Let me put arrows here in order to denote the rectangular coordinate system, and these 2 points are now placed in a rectangular coordinate system. I can uniquely identify now as I mentioned, I can uniquely identify the points over here, and on y-axis let us say this is 1 unit, and this is 2, this is 3, this is 4, this is 5. Now I am asking you a question, what is the distance between these 2 points, and therefore I need to identify the points A and B with respect to our coordinate system. What is a coordinate system? What is the x coordinate over here? The x coordinate over here is 1 and y coordinate over here is 2. So A12 is the unique representation with respect to our coordinate system of point A. In a similar manner, if you consider point B, the y coordinate is 5 and x coordinate is 4. So 4 comma 5 is the unique identification of this points A and B in this coordinate system. Now if I want to compute the distance between 2 points, what should I consider? So from the basics of geometry or computation, we already know that the minimum distance between these 2 points is the distance covered by a straight line joining these 2 points. That is what this minimum distance is. Now I want to have an estimate in terms of length, in terms of a single number for this particular line. That means I want to identify what is the length of this particular line. So let us say it is L. L is the length of this particular line, which is distance of AB. How will I estimate this distance? This is what we have covered in the third video. So in this particular case, we have an exact tool for identifying the distance, because we can apply the Pythagoras theorem which is available to us. So what is a Pythagoras theorem? For Pythagoras theorem, we need first of all we need a right angle triangle. So in this case, let us take the right angle triangle, and let the right angle triangle be like this. This is a right angle. Let us denote this point as, say, point C. What is a coordinate? What will be the coordinates of point C? Because in our rectangular system, every point is uniquely identified. So the point C, because this is by dropping the perpendicular, will have x coordinate which is similar to B, and y coordinate which will be similar to A. So C is 4 comma 2. Just check, C is 4 from here and 2 from here, so 4 comma 2, right? Now when I talk about distance on a line, I know let us say if some point is here and some point is here, and you ask a question, what is the distance between, let us say this is a point M and this is a point N, what is the distance between M and N? You can easily say that the distance between M and N is actually 4 minus 1, which is 3 units. So same logic is applicable over here when I am talking about distance of these 2 points, that is A and C. So what is the distance of A and C? It is actually 4 minus 1, that is a distance of point AC, or I can say AC is equal to this, or you can, to be very precise, you can say length of AC is equal to 4 minus 1, which is equal to 3. Now what is the length of this point C? Length of the line segment joining points B and C. That is the next question that you can ask. Again the same logic applies, because this point is parallel to y-axis. Consider any 2 points which are on y-axis having similar y coordinates. So in particular this point, let us call this point as P and Q, and the length of PQ is actually 5 minus 2. This is the length, 5 minus 2, which is 3 units again, right? So now you have the which will be the length of BC as well. So if this is clear, then my length of BC is again 5 minus 2, which will be equal to 3 units. And hence, if now I have the entire setup which is required for applying the Pythagorean theorem. That is, first thing that I have is the length of AC. The length of AC that is given here is 3 units, and the length of BC is also 3 units. And then I can ask a question, what is the length of this particular, that is AB. So I am asking a question, what is AB? But if I invoke the Pythagorean theorem, then it will be simply AB square is equal to AC square plus BC square, and that if essentially gives me 3 square plus 3 square, and that will be equal to 9 plus 9, which will give me 18. Let me write to be precise, 9 plus 9, which is 18, and therefore AB, the length of AB will be, very simply put, the length of AB will be square root of AC square plus BC square, because we are talking about length which cannot be a negative number, so I am taking a positive square root, is square root of 18, and that essentially means it will be 3 square root of 2, 3 root 2, because 9 into 2 is 18, and if you take the square root of that, that is square root of 9 is 3, and square into 2, which square root is square root 2. So this gives me the answer for this particular problem. Now let us generalize this problem into a setup where I don't have any specific numbers, in a sense that I don't have any specific numbers of points like 4, 2, or all these things are not given, but a general coordinate system is given to me. Let us write this as a general coordinate system is given to me, and I have points A, B, and let those points may have any parity. So in this case, let us say the points are x1, y1 and x2, y2. And now you are asked a question, how to resolve the problem of a distance, that is the minimum distance. So the minimum distance is a straight line joining these 2 points. So let me join the straight line joining the 2 points. Yeah, so in this case what I will do is I will simply start with my job of invoking the Pythagorean theorem, which I will do in this manner. That is, now if you look at the point A, and if you look at let us name this point as C, what can you say about the coordinate of point C? The coordinate of point C will be x2 on x-axis, and on y-axis the coordinate will be y1. How I am deriving this? Because if you look at point B, the coordinate of coordinate on x, the x coordinate of B will be same as the x coordinate of C, because they are on one vertical line. In a similar manner, if I look at points A and C, they are on the same horizontal line, therefore the coordinates of y will be same for them. So y1 is the same coordinate for both of them. Now I have the basic setup. Apply the same formula that you used here, that is AB square is equal to AC square plus BC square. Okay, and therefore AB, that is distance between 2 points A and B, is square root of AC square plus BC square. Now you answer the question, what is the length of AC? Length of AC will be simply this length, that is x2 minus x1. So it will be x2 minus x1 the whole square. And what is length of this particular number? This is the length. So length of BC will be plus BC square, that is y2 minus y1 the whole square. Okay, so this formulation will be called as distance formula for AB. Now when you get this final formulation, this is the final formulation of your AB, and when you get this final formulation, you can easily see that the intermediate point, that is this C, is auxiliary. You don't require it in while computing it. It is behind the scenes, it is working behind the scenes. So now if I have been given any 2 points, I don't have to work out all these things. I can simply start with the point and I can simply answer the question, what is the distance. Let me elaborate it in more detail by taking one example. So here is an example. For simplicity, let us take the one point to be origin. So let it be O, which is 0, 0, and let the other point be P, which is say 4, 3. Right? And you are asked to compute the distance between these 2 points. How will you compute? That essentially reduces to a very simple formulation that you need to do, which is OP is equal to square root of, okay, so let me write this in the form of x1 y1. So this is x1, this is y1, this is x2, this is y2. Okay, now just apply this formula which is given for AB. Very simple. So it is 4 minus 0 the whole square plus 3 minus 0 the whole square, and that will essentially give me 4 square is 16 plus 3 square is 9, 25, square root of 25 is again 5. That's the answer. So distance of point P from the origin is 5. Now here one interesting thing has happened. If I translate this in general notation, that if I want to compute distance of any point from the origin, I can actually get one interesting formula, that is OP will be equal to, use this notation now, x2 y2, simply square root of x2 square plus y2 square. This is another general formula that we have derived for finding the distance of a point from the origin. So we have a distance formula for a set of 2 points, for 2 points that are given to me. Okay, so this covers all the cases that you need to study for a set of 2 points. Now a case generally happens which is very crucial, and that is given by section formula, and it's an internal cut of a internal section. So you have been given the coordinate plane, you have not been given a coordinate plane, but what you are actually asked is points A and B are there, and using points A and B you need to find the coordinates of a point P which cuts this line AB or line segment AB in the ratio m is to n. So this is a general term that comes. So I can relate this section formula with some mobile tower or something like that. For example, there are some buildings associated here with at point. If there is a building at a point A and there is a building at a point B, and you want to construct a mobile tower at point P, and your mobile tower is designed in such a way that the range of mobile tower will reach a distance of m is to n in the ratio of m is to n. That means your mobile tower will have some range which is proportional to m is to n. And then you need to decide what should be the point P, so that these 2 buildings which are located at points A and B that receive the signal of your mobile tower. So let me reiterate the question. There are 2 buildings A and B that are located, there are 2 buildings A and B. A mobile company wants to build a mobile tower, but the mobile tower has a restriction that the range of the mobile tower on the left and right is in the ratio of m:n, and now you want to locate the mobile tower in such a way that building A also receives the signal and building B also receives the signal. This is the problem. So I will try to solve this problem using our mathematical formulation that we have for coordinate system. So because these A and B belong to some coordinate system, let us say their coordinates are x1 y1 and x2 y2, and the task assigned to you is, on this straight line, find the point P such that the ratio of the ranges of the mobile tower is in m:n. So what are the given things? The given things are point A with coordinate x1 y1, point B with coordinate x2 y2. The ratio, that is, there should be some point P with some unknown coordinates, but the ratio AP upon PB is given to you, and it should be m:n or m upon n. So these are the things, and your entire exercise is to find what this P will be. This is what we will try to address in this particular session. So let us go ahead and try to solve this problem. Okay, so let me do one thing. Let me redraw the diagram. That is, this is point A, this is point B, and I have joined a line between these 2 points. Let me be very precise in joining the line. Let me erase the unnecessary line. Yes, and there is a point P associated with this line. Let us say it is somewhere here, and that point P cuts the line in m:n ratio. So m is here, n is here, and the point P is here. But let me write the coordinates of the point on the left hand side so that it will not intervene into my diagram. So this is x1 y1, this is x2 y2. Okay, now we no longer need this diagram, so just focus on the diagram which is drawn in red. Now if I want to determine this, then I need to invoke some basic principles, basically similarity of triangles from your school level mathematics. So what I will do, as I did in distance formula, I will drop a perpendicular and I will connect it so that it forms a right angle triangle. Same thing I will do again over here, and I will connect with it in this fashion. Okay, and now let me name these points. So let us say this point I have given the name P. So let us say this point is actually Q, and this point, let me name it as R. Okay, so there are now two triangles in picture. One is triangle ARP, another one is triangle PQB. What can you say about these two triangles? Again, I am using basic elementary concepts of geometry. First thing that I notice is the lines that are drawn here. These two lines, they are parallel lines, and the red line that is passing through this, that is the red line on which the points A and B lie, is actually a transversal to these 2 points. Then immediately I can draw your attention to the fact that these angles are same. Both angles are same. Okay, so now these two angles are same, and now you look at this angle, which is a right angle. Therefore this angle also must be same. That is, angle R and angle Q are both 90 degrees. Angle A and angle P both are theta. Now if you look at any triangle, let us say triangle ARP, what is the total sum of all the angles? It is simply 180 degrees, which is again an elementary fact in our coordinate geometry or in our geometry, basic geometry, no need of coordinates. Now you can use that fact and say that this angle will be 180 minus 90 minus theta, right, which essentially reduces to simply 90 minus theta. What can you say about this angle then? Again it will be 90 minus theta. I hope I made it clear. Now both angles are 90 minus theta. So what we have established now is all the angles of triangle ARP and triangle PQB are same. Therefore, I can say that triangle ARP is similar, this is again a notation of elementary geometry, to PQB. Again I will invoke the similarity properties of the triangle, and then I can say that all the sides of these triangles, the corresponding sides of these triangles will be in certain ratio. Therefore, I can write a fact that AP, which is this side, AP, and PB, so AP is to PB, must be equal to AR, which is this side, AR is to PQ upon PQ. Okay, and again the third side that is left is RP, or you can say PR, doesn't matter, RP is to BQ. Okay, but it is already known that my AP is to PB is of the form M is to N. So I can simply put it as M is to N. Now some miracle happens. What is a miracle? The miracle is AP is to PB is lying on a it's not horizontal, it's a slanted line, and therefore I cannot talk about the lengths of these lines, or I have to use a distance formula to talk about lengths of these lines. But the case where we are considering AR and PQ, these lines are actually horizontal lines, right? So they are parallel to some imaginary x-axis which exists, correct? Another thing that happens is these two lines means these lines, this line and this line, they are vertical lines and they are parallel to y-axis. So I can talk about their y coordinates or their lengths. So I will invoke this fact and write my ratio M is to N, which comes from the given data, which is given here, M is to N. So this part I have already used, I don't want to use it now. Let us take this AR upon PQ. What is AR? AR is actually the length of this particular line segment. Okay, so do I know the coordinates of R? Yes, I do know. On x-axis, we have to travel x units to reach R, and on y-axis we need to travel y1 units to reach R. This x is unknown, remember? So in particular, my length will be x minus x1. And what is the length of PQ? Again I will invoke the same logic. On x-axis I have to travel x2 units to reach the point Q, and on y-axis I need to travel y units to reach the point Q. So the coordinates of Q are x2 comma y. Okay, so but for this particular exercise the x coordinates only matter, so it is x2 and the coordinate of P is x, therefore it is x2 minus x minus x1 upon x2 minus x. You can also do the similar exercise for RP and BQ. What is that? RP is the length in y direction, it's a vertical direction, right? So in this case the x coordinates will be same, so you will no longer bother about x coordinates. What you will bother about is only y coordinates. So what will be the length of this in y minus y1? Remember, this is y and this is y1, so the length will be y minus y1 upon what will be the length of this particular thing? It will be y2 minus y. This is an important relation, or this is a very important identity that we will use again and again in order to solve problems. Let us look at this identity and try to see whether we can come up with a solution to these points x and y, right? So let us go ahead and do some computation. So let us take the first equality, that is m is to n is x minus x1 and x2 minus x1. Simply cross multiply this, that is m times x2 minus x is equal to n times x minus x1. Now what you get? Now you can actually multiply m throughout the left hand side and multiply n throughout the left hand side, and what you will get is m times x2 plus n times x1 will be equal to m plus n times x. If you don't get this, pause a video and see whether you are getting this. You should be able to get it. It's very easy. Then you will get x is equal to, because m and n are non-zero quantities, they cannot be 0. If they are 0, we will not be solving this problem, right? So we can simply divide both sides by m plus n, and therefore we will get this to be equal to m is to n. X is equal to m is to n. In a similar manner, what I will do is I will take this and this together, and what you will get for y, that's what we will see. So it's m times y2 minus y is equal to n times y minus y1. Let me erase it, y minus y1. Okay, again the same logic applies. You have to you have to multiply throughout, and you will get something like m times y2 plus n times y1 is equal to m plus n times y, and therefore you will get y to be equal to m times y2 plus n times y1 upon m plus n. Therefore the coordinates of P, the new point P, which was unknown earlier, is now m times x2 plus n times x1 upon m plus n, and the coordinates of y are m times y2 plus n times y1 upon m plus n. These are the coordinates. So this simply answers our question of what are the coordinates of P. Now there can be another question, that if so essentially now if you go to our mobile tower discussion, that the point P should be located at this place, right? And you can have you must have solved several numerical problems based on this in your practice assignment and graded assignment. Now the next question that comes is, sometimes you may be given all the coordinates of the points A, P and B, and you may be asked to determine what ratio is AP to PB. This also can be a question. So in that case, how to handle the question, that's what we will see now. So in that case, let us take some points. Let us say the points are A is 1 1. Let me write here, A is 1 1, P is say 2 2, and B is say 4 4. So I am taking simple points so that there is a nature of symmetry, so that the calculations are easy. But and let us put them in a proper order in this particular context. So in this case, what I have is x1 y1. This is the point P was denoted by xy, and otherwise it is x2 y2. The point B is x2 y2. So this is our nomenclature, so that I will fit the constraints over here, because now I have been asked what is this m by n. So now you use this particular knowledge, that is m by n, that is AP by PB will be actually, so AP by PB will be actually x minus x1 upon x2 minus x. It's this simple. So in this case you don't have to worry at all about the coordinates that are on y-axis. So let us go ahead and solve this problem. So x over here is, according to our notation, 2 minus x1 is 1, 2 minus 1 upon x2 minus x. What is x2 here? It's 4, and x is obviously 2, 4 minus 2, so this will give me 1 and this will give me 2. So my AP by PB is 1 by 2, so I know this is 1 upon 2, or you can write AP by PB is 1:2. That means the point P cuts the line segment AB into 1:2 ratio. Okay. And the third type of question that may come is, suppose you have been given these 2 points A and P, and you have been not given this point. Let us say this point is K, and then you may be asked to compute this point K. In that case, what you will do? Let us do it now, because I have anyway not used what is the value of K, right? So in that case, I know that AP is to PB is in the ratio 1:2, and I have some unknown value. Let us say this was not given to you, and you have been told that this is equal to some K. Okay, and your goal is to determine K. Anyway, I have not used the Y values, right? So I can still use this problem to solve that question. So in that case, what you need to do is you take this third one, that is y minus y1 and y2 minus y. So what is y here? Y was 2. So 2, let me write for more clarity. Y minus y1 upon y2 minus y. So what is y? Y over here is 2 minus y1. Y1 is simply 1, so I don't have any issue. And y2 minus y, my y2 is now unknown, so it is k minus, what is y? Again 2, right? So I can so if you solve this, you will get this to be equal to 1 upon k minus 2 will remain k minus 2, but here I have 1:2. So what I will do is I will simply take this as 1, so just multiply both sides by k minus 2, and 2 times k minus 2, you will get this to be equal to 2, and that simply forces me to say k is equal to 2 plus 2, which is equal to 4. So I got the answer, right? So this is how you will solve all 3 kinds of problems related to section formula. That's all for now.